Imagine holding a rock in your hand that is so precious it could pay for every building, bridge, and city on Earth 1 billion times over. Right now, high above your head in the dark night sky, a gigantic world made of pure, glittering gem is racing around a burning star. It is not a fairy tale or a movie trick, but a real place where whole mountains are carved out of solid diamond. If you could somehow touch it, you would be looking at the single most valuable object in the known universe. If you love uncovering the wildest and most mind-blowing secrets hidden across our universe, hit that subscribe button right now. Joining our community means you will always be the first to explore real scientific discoveries that sound totally impossible. We break down the biggest cosmic mysteries into simple stories every single week. So stick around and let us explore the night sky together. Look up at the stars on a clear, dark night in late winter or early spring. If you point a telescope toward the constellation called Cancer, you're looking toward a quiet neighborhood 40 light years away from Earth. 40 light years sounds like a small number in space, but it equals roughly 240 trillion miles. That is so far away that light itself, traveling at almost 186,000 miles every single second, takes 40 full years to make the trip. In that quiet neighborhood, there's a star called 55 Cancri. To the naked eye, it looks like a faint dot of yellow light, slightly smaller and cooler than our own sun. For a long time, astronomers thought this faint star was just another ordinary neighbor in our section of the Milky Way galaxy. They mapped its position, wrote down its brightness, and moved on to look at bigger and flashier objects deep in space. However, stars often hide incredible secrets behind their calm and quiet glow. In our own solar system, we have 8 major planets that follow strict and familiar patterns. We have small rocky worlds like Mercury, Venus, Earth, and Mars, sitting close to the warmth of the sun. Further out, past a wide ring of asteroids, we have giant balls of gas like Jupiter and Saturn, along with ice worlds like Uranus and Neptune. For hundreds of years, humans naturally assumed every planetary system in the galaxy followed this exact same basic design. We believed that rocky planets everywhere were made out of the exact same basic ingredients that make up our home planet. On Earth, those ingredients are mostly iron, oxygen, silicon, and magnesium. Earth is a giant ball of rusty rock with a heavy metal core buried deep inside its belly. Carbon is the building block of all living things on Earth, but on a planetary scale, our homeworld is actually quite poor in carbon. Carbon makes up less than 0.1% of Earth's total weight. Almost all the carbon on Earth is locked up in living plants, animals, coal, oil, and the thin layer of gas floating in our sky. We live on a planet made of silicate rock, which is basically the same material as common sand and granite. So when astronomers began searching for worlds orbiting other stars in the late 1990s, they fully expected to find more silicate rocks and gas giants. They figured that nature was a simple cook, using the exact same recipe across the entire cosmos. They thought every rocky planet out there would just be a slightly larger or slightly smaller version of Earth or Mars. But the universe was about to prove that its cosmic kitchen has recipes far stranger than anyone had ever dreamed. In the year 2004, a team of astronomers using powerful telescopes on top of mountains in Texas and California noticed something strange. The star 55 Cancri was wobbling back and forth in space ever so slightly. That tiny wobble meant that an invisible gravity pull was tugging on the star, swinging it back and forth like a heavy pendulum. By carefully measuring the rhythm of that wobble, scientists realized that a hidden planet was whipping around the star at blinding speed. They named this newly discovered world 55 Cancri A, though scientists also give it the friendlier name Jansen. When they calculated its orbit, the numbers were so extreme that many astronomers double-checked their equipment to make sure they had not made a silly math mistake. Jansen was not orbiting millions of miles away from its star like Earth does from the sun. It was tucked so close to its star that it completed a whole year in just 18 hours. Imagine celebrating a brand new birthday every single afternoon. While Earth takes 365 days to make one full trip around the sun, Jansen zooms around its parent star in less time than it takes to watch a few movies and sleep through the night. It is roughly 26 times closer to its star than Mercury is to our sun. Being that close means the planet is trapped in a non-stop furnace of crushing heat and intense radiation. Did you know a planet could orbit its star in less than a single day? If that 18-hour year blows your mind, take a second to hit the like button and drop a comment below telling us what you would do if a year lasted only a few hours. Your support helps us share these amazing cosmic facts with more space lovers just like you. When scientists first looked at Jansen, they tried to fit it into their old familiar models of how planets work. They initially assumed it was just a massive ball of rock surrounded by a thick, suffocating envelope of water steam or gas. Because it has a mass about 8 times heavier than Earth and a diameter roughly twice as wide, scientists classify Jansen as a super-Earth. A super-Earth is simply any rocky planet that is significantly larger than Earth, but smaller than cold gas giants like Neptune. For several years, researchers wrote papers describing Jansen as a sweltering ocean world where water was kept in a weird, dense state by immense pressure. But as telescope technology improved, a group of scientists led by Yale University astronomer Niku Madhusudan decided to take a closer look at the parent star itself. They analyzed the light coming from 55 Cancri and measured the chemical elements floating in its glowing outer atmosphere. What they found turned the whole story upside down. The parent star contained vastly more carbon than our own sun, while having much less oxygen. In our solar system, oxygen is abundant, which is why oxygen combined with silicon to build the rocky mantle of Earth. But around 55 Cancri, carbon was the dominant heavy element in the surrounding cosmic cloud when the planets were born billions of years ago. This gap between expectation and reality completely changed how scientists viewed Jansen. Instead of building a planet out of silicon and oxygen, nature had used carbon as the main ingredient. When a planet forms in an environment rich in carbon and poor in oxygen, its entire chemical recipe changes from top to bottom. Instead of granite rocks and iron-rich dirt, you get massive deposits of graphite, charcoal, and glittery diamonds. To understand how a whole world can turn into a jewel, you have to look at how diamonds are actually made right here on Earth. On our planet, diamonds are quite rare and precious because carbon is scarce in the deep mantle. A diamond forms when plain carbon, like the black graphite found inside a common pencil, gets squeezed under enormous pressure and heated to thousands of degrees deep underground. The intense pressure forces the carbon atoms to lock together in a tight crystal pyramid structure that is nearly impossible to break. On Earth, deep volcanic eruptions occasionally blast these hidden diamond crystals up toward the surface, where humans dig them out of deep mines. But on Jansen, those intense pressure and heat conditions are not just happening in tiny pockets deep underground. They are happening across the entire planet, from its surface all the way down to its center. Scientists calculated that at least 1/3 of Jansen's total mass is made of pure carbon. Given the immense weight of the planet pressing inward, that carbon cannot stay as soft graphite. The crushing gravity squeezes that carbon with millions of times more pressure than the air pressing against your skin right now. Under that unbelievable weight, vast layers of the planet's interior are squeezed directly into solid diamond. Think about what that actually means in plain terms. If you took the total weight of planet Earth, about 1/3 of it would be roughly 2 trillion tons. On Jansen, that entire staggering weight is pure diamond. There's more diamond locked inside this single planet than all the gold, silver, jewels, and money that have ever existed in human history combined. It is a world where whole mountain ranges and deep inner layers are carved out of gem material. Before we reveal what the surface of this diamond world actually looks like, here is a detail that surprises almost everyone who learns about space chemistry. You might picture a diamond planet as a cold, bright crystal floating peacefully in the dark void, sparkling like a giant ring in a jeweler's window. But the reality on the ground is vastly terrifying, hot, and wild. Because Jansen sits so ridiculously close to its parent star, its surface temperature reaches a scorching 3,600 degrees Fahrenheit. That is well over 2,000 degrees Celsius. To put that number into perspective, steel melts at around 2,700 degrees Fahrenheit. Commercial ovens used to bake pizza operate at around 500 degrees. Jansen is hot enough to melt solid iron, gold, and rock into runny liquid in a split second. Because the planet is so close to the star, it is also locked in place by gravity, a state scientists call tidal locking. Tidal locking means the exact same side of the planet always faces the star, while the other side faces away into permanent darkness. It is the exact same reason why humans on Earth only ever see one side of our moon. One half of Jansen is stuck in an eternal blinding day, while the other half is trapped in a forever night. On the day side, the blistering heat turns the outer layer of graphite into vast, glowing oceans of liquid lava. But this is not normal lava like the melted rock you see erupting from volcanoes in Hawaii. This is liquid carbon lava mixed with glowing pools of melted silicon and iron. Giant dark continents of solid graphite float like heavy soot rafts on top of these glowing yellow oceans of liquid carbon. Directly beneath those dark graphite continents lies the main attraction. As you travel just a few miles down beneath the surface, the weight of the outer crust squeezes the carbon tighter and tighter. The graphite collapses and transforms into a thick, continuous mantle of solid diamond thousands of miles deep. It is a structural shell of brilliant crystal wrapped all the way around the metal core of the planet. Are you enjoying this deep dive into the weirdest worlds in our galaxy? If you are amazed by the thought of liquid lava, oceans flowing over diamond mantles, smash that subscribe button right now and turn on notifications. We have dozens of thrilling space mysteries coming your way, and you will not want to miss a single one. For a long time, scientists wondered what lay between the diamond mantle and the freezing dark side of the planet. They originally expected the dark night side to be completely frozen solid, locked in an endless deep freeze because it never sees the light of its sun. But when NASA used the Spitzer Space Telescope to measure the heat coming off the planet, they found something that completely shocked them again. The night side was certainly cooler than the day side, but it was still wildly hot, hovering at around 2,000 degrees Fahrenheit. Heat was somehow traveling from the blazing day side all the way around to the dark night side. On a normal airless rock, heat cannot move around to the back very well. The huge heat difference meant that something was actively carrying energy around the planet like a giant cosmic conveyor belt. Scientists realized there were only two possible explanations for this heat transfer. Either the planet was covered in a massive global ocean of flowing lava that recirculates heat, or it possessed a thick atmosphere of gas, blowing hot winds from front to back. For many years, researchers argued fiercely about whether a small, superhot planet like Jansen could even hold onto an atmosphere at all. Most scientists believed that the fierce wind of charged particles blowing off the nearby star would have blasted any air away billions of years ago. On Earth, our magnetic field protects our atmosphere from being stripped away by the sun. But Jansen sits so close to its star that the solar radiation is thousands of times stronger. Traditional models predicted that Jansen should be a bare, naked rock stripped completely clean by its star. Once again, the universe proved that our expectations were totally wrong. In May of 2024, astronomers used humanity's newest and most powerful space observatory, the James Webb Space Telescope, to settle the mystery once and for all. They pointed the telescope's mirror at Jansen as the planet passed behind its star and carefully measured the faint light filtering through the edges of the world. What the James Webb Space Telescope found was a landmark discovery in modern space science. Jansen actually has a thick, heavy atmosphere wrapped tightly around it. But it is not an atmosphere you or I could ever breathe. It is made mostly of carbon monoxide and carbon dioxide gases, along with other carbon-based vapors puffed out by the boiling oceans on the surface. This atmosphere acts like a heavy blanket, keeping the planet from cooling down and driving super-hot winds across the surface at thousands of miles per hour. The heavy gas boils off the lava lakes on the day side, sweeps across the diamond mantle regions, and carries blistering heat over to the night side before cooling down and raining back down as heavy liquid soot. This discovery marked the very first time humans have ever detected a clear atmosphere around a rocky super-Earth outside our own solar system. It showed scientists that super-Earths can continuously rebuild their atmospheres from the inside out. Even as the star blasts air away into space, the boiling diamond and carbon mantle underneath keeps bubbling up new gas to replace it. When you stop and think about it, Jansen is a world that defies almost every rule we learned in school. It is a world where the dirt is soot, the rocks are gems, the oceans are liquid lava, and the air is thick carbon gas. It sounds like a mythical underworld from ancient legends. Yet it is sitting right out there in space, churning through its 18-hour orbit day after day. Before we look at whether there are other diamond worlds hiding in the deep dark of space, let us share a detail that researchers love to point out to make people realize how strange this place truly is. If you could somehow send a probe to mine just a tiny fraction of Jansen's diamond mantle, that small haul would instantly crash the entire global economy on Earth. On Earth, diamonds are expensive because their supply is tightly controlled and natural gem-quality stones are hard to find in the ground. But value is entirely based on scarcity. If a spaceship returned to Earth carrying a mountain of pure diamond, the price of gems would instantly drop to zero. A diamond would become as cheap and common as a driveway pebble or a handful of backyard dirt. Does the thought of a whole sky full of hidden jewel planets change how you look at the stars? Drop a comment down below and tell us if you think humans will ever build spaceships capable of visiting these distant worlds. We read through your comments and love seeing your theories, so join the conversation right now. As wild as Jansen is, it is not the only diamond world scientists have spotted across the galaxy. The universe seems to love repeating its best tricks whenever the right chemical ingredients come together under high pressure. In 2011, a team of radio astronomers discovered an even stranger jewel planet sitting thousands of light years away in the constellation Serpens. This world orbits a rapidly spinning dead star called a pulsar. Pulsars are the crushed leftover cores of giant stars that exploded in supernovas. They spin hundreds of times every single second, sweeping beams of intense radiation across space like a cosmic lighthouse. Astronomers named the planet orbiting this dead star PSR J1719-1438b. Scientists originally expected planets around pulsars to be rare or completely destroyed by the massive star explosions that created the pulsar in the first place. But when they measured the orbit of this object, they realized it was the surviving core of a former star that had its outer layers completely eaten away by its neighbor. What was left behind was a planet-sized mass made almost entirely of ultra-dense carbon and oxygen. Because the gravity and pressure inside this remnant are even higher than on Jansen, scientists calculated that this object is essentially one single massive diamond floating in deep space. It is roughly the size of Jupiter, but thousands of times denser than anything found in our solar system. Even right here in our own backyard, inside our familiar solar system, diamond physics plays a huge role. Scientists at laboratories in California and Germany have used powerful lasers to squeeze carbon materials to extreme pressures, simulating the interiors of our local ice giants, Uranus and Neptune. For a long time, school textbooks described Uranus and Neptune as simple balls of water, ammonia, and methane ice. But experiments conducted over the last few years show that thousands of miles beneath their pale blue cloud tops, the extreme heat and pressure split methane gas molecules apart into hydrogen and carbon atoms. Once the carbon is freed, the intense pressure squeezes it directly into diamond rain. Scientists now believe that deep inside Uranus and Neptune, it literally rains solid diamond hail down through the liquid interiors. These falling diamond hailstones sink through thousands of miles of slushy mantle until they reach the solid cores, creating massive diamond layers right inside our own neighborhood. This realization shifted how astronomers view the entire galaxy. Diamond-forming environments are not rare, freaky accidents that only happen once in a trillion years. Nature uses high pressure and heavy carbon to build diamond structures all over the universe, from nearby giant planets to strange super-Earths 40 light-years away. Right now, as you listen to these words, the situation on Jansen is undergoing active study by top research teams around the globe. Scientists are using ground-based observatories and space telescopes to map out the exact weather patterns on this alien world. They are watching how the planet moves across the face of its star to see if its atmosphere changes over time. They are trying to answer big, fundamental questions that affect our understanding of how planets form. How common are carbon-rich clouds in the galaxy? How many other star systems are out there right now building diamond crusts instead of silicate rocks? Could there be colder diamond planets floating further out from their stars, where the surface is not boiling lava, but mountains of cool, sparkling crystal under clear skies? If cold diamond planets exist out in the dark, they would present a completely different kind of world. Instead of red lava lakes and carbon soot, they might have smooth crystal plains, clear jewel canyons, and thick glaciers of frozen carbon dioxide. They would be quiet, silent monuments of solid gemstone drifting through the void of space. What do you think is the most exciting part of this discovery? Is it the boiling lava oceans, the thousands of miles of diamond mantle, or the fact that it rains diamonds on planets right here in our solar system? Hit the like button and post your thoughts in the comments so we can hear what caught your attention the most. When we zoom out and look at the big picture, discoveries like Jansen do something deeply important for all of us living on Earth. They remind us that our home planet is just one small result out of an infinite number of cosmic combinations. For thousands of years, humans looked up at the night sky and imagined that other worlds must look just like our own backyard. We imagined green fields, blue oceans, and familiar mountains on every distant star. Instead, modern science shows us that reality is far wilder, more creative, and more diverse than human imagination ever was. The universe builds worlds out of glowing lava, worlds made of solid crystal, worlds where it rains iron from the sky, and worlds where time moves so fast that a year passes before you can finish your day. Understanding these strange places helps scientists figure out how rare and special planet Earth truly is. Earth sits in a perfect sweet spot. It has just the right amount of water, the right balance of carbon and oxygen, and the right distance from its star to allow liquid oceans, gentle weather, and living creatures to thrive for billions of years. While a planet made of pure diamond sounds like the ultimate treasure chest, it is actually a deadly barren hellscape where no living thing could ever survive for a fraction of a second. The sparkling diamonds of Jansen are locked away in a burning vault of lava and poison air. It turns out that plain old dirt, liquid water, fresh air, and green grass are infinitely more precious than trillions of tons of solid gemstone. The search for exotic worlds is just getting started. Every single year, space agencies launch smarter satellites and sharper telescopes into the dark. We are mapping thousands of new worlds orbiting distant suns, constantly pushing back the borders of what we know about the galaxy we live in. Who knows what incredible secret we will uncover next? Maybe we will find worlds made of solid ice that burn with invisible heat, or planets with rings so massive they blot out their own suns. The cosmos is full of incredible surprises waiting to be found, and we are living in the golden age of space exploration. If you enjoyed this journey to the diamond world of Jansen and want to keep exploring the deep secrets of our universe, make sure to hit that subscribe button right now. Turn on the notification bell so you never miss a new story, and share this video with a friend or a family member who loves space as much as you do. Before you go, here's a question to leave in the comments below. If technology existed to instantly visit any planet in the galaxy for 5 minutes in a safe suit, would you want to stand on the night side of Jansen and look out at a sky filled with glowing lava and diamond hills? Let us know your answer down below. Thank you so much for spending your time with us today. Stay curious, keep looking up at the stars, and we will see you in the very next video.